Hello, everyone, and welcome to day 2 of Responding to Societal Needs with 3D Geology, an international perspective. So we're thrilled to have over 1,400 registrants that have, looking to participate in these sessions from over 79 countries. So that's a phenomenal audience, and we're looking forward to a really great panel discussion with our panelists, as well as a follow-up discussion later where we hope to get to a number of great questions and address some of the questions that came in from day 1, as well as kind of get to some feedback from you guys on a couple questions that we're going to be putting out to you as well. So first up is going to be Dr. Edward Sudicky, Professor Emeritus from the Department of Earth and Environmental Sciences at the University of Waterloo and founder and board chair of Aquanti Incorporated, a U of A spin-off company specializing in advanced hydrosystem simulation. He received his BASc degree in civil engineering, an MSc and a PhD degrees in earth sciences from all at the University of Waterloo. Dr. Sudicky has received numerous awards and been a distinguished lecturer many times. He is a fellow of the Royal Society of Canada, the Canadian Academy of Engineering, and the American Geophysical Union and the Geological Society of America. Next up, we have Scott Kuykendall, who is a water resource specialist for the McHenry County Department of Planning and Development. He is responsible for overseeing the county's specific studies on groundwater, helping to develop public policy relating to water resources, maintaining the county's compliance with federal and state stormwater regulations, and conducting education and outreach for the community. Scott is a member of many organizations dedicated to water resource management, natural areas restoration, and sustainability. Scott earned a Bachelor of Science degree in Geography from the Southern Illinois University and a graduate certificate in Environmental Management and Sustainability from the Illinois Institute of Technology. Scott will provide the perspective of an end user of 3D mapping. The county that Scott's working with currently uses 3D mapping for regulatory purposes to protect groundwater recharge, land use planning, and protect water quality. And for the educational purposes, they're using it to inform elected officials, students, and the general public about groundwater. Next up, we have Dr. Michael Kehinde. Michael is a Prince II certified project manager, chartered geologist, and lead hydrogeologist in Hertfordshire and North London area of the Environmental Agency in England. Michael works with stakeholders to ensure availability and security of water for people, nature, and livelihoods. He has lots of experience leading people and managing projects in line with the Environmental Agency's ambition to be a modern regulator and deliver outcomes that create a better place for people and nature. Scott has also worked on many projects in the water and environment sector in Europe and Africa as senior university academic and consultant to industry, to national governments and UNICEF on a spectrum of local, national, and international projects, and was involved at various times in policy and strategy formulation for water resource management. Michael is passionate about sustainable management and wise use of resources and blending policy with practice for desired environmental outcomes. Thus far, Michael has commissioned 6 geologic mapping and 3D modeling projects as part of an ongoing strategy to improve the regulation of water resources in Hertfordshire and North London area. Next up is Dr. Helen Reeves, who is an international and leading and renowned engineering geologist specializing in geohazard characterization, assessment, and communication. Helen has a wealth of experience in engineering geology and geohazard research with over 30 peer-reviewed publications, policy review documents, reports, and industry commissioned reports covering a range of topics from geohazard characterization and assessment, mapping, rock mass characterization, and geomechanics. Prior to joining Jacobs, Helen was also the Science Director for Engineering, Geology, and Infrastructure at the British Geological Survey. Helen has provided regular technical advice to both the UK and Scottish governments through her BGS, British Geological Survey, and Natural Hazard Partnership roles. Additionally, she has advised a number of international boards, technical scientific groups, and industry stakeholders. And finally, we have Dr. Roland Baumberger. Roland is passionate about new ways of thinking and is always looking for innovations to meet the requirements of tomorrow. Roland completed a PhD in structural geology from the University of Bern in Switzerland. Prior to that, Roland had lots of experience working with computers back since the 1980s, focusing on gaming and later on programming and DTP. His passion has led him to the internet industry as a project manager before the internet bubble in the late 1990s. In 2008, Roland joined the Swiss Geological Survey as a project manager for 3D geologic modeling in order to set up the new department covering this topic. Since 2014, he has been the head of the data management and geoenergy departments, where he is responsible for 3D modeling of the deep subsurface, the management and visualization of geologic data, and geoenergy. So thank you to our panelists, and we're going to now transition over into the first question that is going to be put forward, which is, how has 3D geology changed the role of geologic survey organizations, and how do you see this role evolving over the next 10 years? So why don't we throw that over to Dr. Roland Baumberger to kick that one off.
Okay, thank you, Kelsey. In short, for me, it's the transition from maps to models to services finally. Because when I started to work at the Swiss Geological Survey 12 years ago, we were a traditional map producer that was just about to take the advantage of the possibilities of digital map production. And then came 3D geology and changed the way we had to think our products fundamentally. And now, after having rushed up the hill, we learned that our customers do not want finished and inflexible products, but they want to have, or they want to receive, input data for their own work. And they need services that allow them to tailor the geological information provided by the GSOs to their needs. And in the future, I think GSOs, they will evolve to be service providers, because geological products are not an end to themselves for GSO, as we heard 2 days ago, but because this data should always serve a specific application or issue. So our products underpin the data services we will provide. And these services might not be free of charge at all times, but free access to data will be key. That's my statement to this question. Thank you.
Okay, thank you very much for that. Why don't we switch over to Dr. Helen Reeves?
Thank you. Absolutely revolutionized how geological surveys work. I think also it's revolutionized, as Roland has just said, how geological surveys now engage with their stakeholder communities. It's given a new life to geological information and data, and how that's being used and taken forward by stakeholders. I think it's widened the spectrum of input of geological information into a whole host of different stakeholders, communities, uses, applications. And I see that evolving as we go forward over the next 10 years. It's opened up people's knowledge of geology and geological processes, and it's taken that forward in agendas, particularly I think in the city agenda, and where subsurface geological data, geoscientific data is now used more regularly by city planners and developers, infrastructure owners, transport owners, asset owners, and starting to use that in integration with other digital data sets to be able to make in the future better, more informed, sustainable decisions about the interaction of the subsurface with utilities, transport, infrastructure, people, and also inform how people live and interact with the subsurface.
Great job there, Helen. Already some of the themes coming across that we had on the first day, in particular the topic of integration. And a good shout out already, the first question, what is a GSO? Just a reminder to all of us to try and reduce the amount of business acronyms that we use. So GSOs are the Geological Survey Organizations. So thanks, Helen. And maybe just across to some of the consumers of geological data, models, information. So maybe Michael, Kehinde, maybe Michael, that's one for you to pick up.
Yeah, thank you very much for that. It's like you said, I'm going to be looking at this from the perspective of a customer. In the first instance, 3D geology capability being made available has made a tremendous impact. And I say this to take us away from the pure scientific reasoning. It has kind of opened up the secret society of geologists with respect to what lies below the ground. With 3D geology modeling capabilities and products, the entire society can now visualize what lies below the ground. And that is a tremendous leap forward because most of the things are no longer out of mind. Now, having said that, I think Geological Society organizations need to maintain a balance between actual geological mapping and adoption of technologies such as 3D modeling. If there is no balance there, we stand the risk of future geologists losing that fundamental know-how that is required by every geologist to make sense of the earth science. So we're kind of doing more of the mathematics than of the geology itself. So it's quite important that we bear that in mind as developers of 3D models and Geological Society survey organizations. I'm seeing greater emphasis on deploying technology and lesser focus on actual field mapping as time evolves. And so there's a need for greater collaboration with industry to make data from ground investigations more readily available. So because there's a humongous amount of data being generated from infrastructure development projects, and that should be made readily available, open data and things like that. My final point to this question is, again, taking us out of this arena. I see a big chasm developing, so a very big gulf developing between countries in the Northern Hemisphere and those in the Southern Hemisphere with regard to institutional capacity development and capabilities with respect to technology and advancement in the use of technology by geological survey organizations. And so how we kind of manage that interface to make sure that the global development in the use of 3D modeling does not suffer from a lack of connection between the North and the South, because eventually it is that will kind of delay whatever progress we want to make. Thank you.
Superb, Michael. There we're almost busting the all the questions that we had coming up here. So a very good a very good roundup, very good round introduction there. And especially, I have noticed the opening up of the secret society there. So yeah, in our green room here, Scott has put his hand up. So Scott, if you just like to respond to that opening question as well.
Yes, thank you. Hello, everybody. And I'm going to give the perspective of an end user as well. And as Michael was saying, this is the 3D modeling allows the world of geology, which is abstract to me. I'm an ecologist. I really have no background in geology, but I have to communicate geological ideas to the general public and our elected officials. So I need to be able to understand well enough to communicate it to others. And the older diagrams that I would have to refer to, like I said, were really abstract, and it was difficult to convey the information to other people. But with the 3D modeling and mapping of our own geology, we can look at a specific location that we all know. We can look at this town, we can look at this river valley, areas that we physically know, and then see the geology underneath. And it has specific resonance with us. We understand where that is. And so we're able to have perspective and relate to it in ways that we wouldn't be able to if it was just abstract concepts. And so by having a 3D map that we can actually look at and utilize, it makes it much more real to the community that I have to communicate with. And so it really is a powerful tool. And I think it's only going to become more and more relevant as time goes on. So that's all I wanted to add.
Yeah,
that's
super.
Great, Scott. And,
Yeah,
and thanks
ahead,
for anyone as with those questions that are coming in. Just to, I guess with so many of them there, if you guys can like the ones that you would maybe want to also see answered, then what we'll try to do is as the questions kind of come in, we'll try to make sure that we get to the ones that with the most amount of likes. So as those questions are coming into the Q&A section, yeah, please click on the ones and like the ones that you would also maybe want to hear more about.
Yeah, so our final fifth panelist.
Go ahead, Holger.
Sorry, yeah, so Ed has put his hand up as our fifth panelist here. Just your statement or your thoughts on that opening questions of the role of Geological Survey Organizations.
Yeah, I'll respond from also the perspective of a user of 3D geology. What we do is we build 3D numerical models of integrated surface, subsurface flow, and transport. And we do this over scales that range from the watershed to the basin to the continental scale. And the questions being addressed by these models are becoming increasingly challenging. For example, exploring concerns about climate change, land use change, groundwater, surface water interactions, population growth, water scarcity, water excess, etc. I might mention that these 3D models are very data hungry, and without ready access to publicly available 3D geologic data, it's a difficult task. Without this data, we're then confronted with the time-consuming task of assembling data from multiple sources, some data reliable, some not so, and then sometimes having to harmonize the data across political boundaries. I would say in going forward, there might be tremendous value in populating a 3D geologic database with relevant flow and transport parameters that are needed by the models. For example, lithofaces and hydrophases used by a numerical model are not always the same. Perhaps concerns such as this could be done by a feedback loop between the numerical modelers and the geologists. We did this recently working with the Geological Survey of Canada and the Ontario Geological Survey, in which we constructed a 3D integrated surface-subsurface hydrologic forecasting model of all of southern Ontario, which is about 85,000 square kilometers. And that was done in 3D. And the model is driven by an ensemble of weather forecasts. The model runs continuously, yields forecasts of soil moisture, stream flows, groundwater levels, etc., for direct consumption by end users. So use of 3D, readily available 3D geologic data is of paramount importance to us.
Super, thanks for that. Okay, back to Kelsey to introduce the second question.
All right, thanks everyone. So for question number 2, we'd like to get your opinions on what do you see as the biggest barrier to this evolving role for geologic survey organizations, or as you guys have described in question 1. So why don't we throw that out to, we'll start with Dr. Michael Kehinde on this one.
Okay. Thank you very much for that. The barriers for development of 3D geology model and uptake. First of all, I think policy and regulatory barriers are quite critical. I'm speaking now from a regulator's perspective and end user perspective. So there are policy and regulatory barriers that need to be taken care of, essentially. Then you have funding and human resources that constitute a major barrier. You have declining trend in students' geological sciences within universities, especially in the United Kingdom, that are closing down geology departments. So that is a major barrier. If geology as a subject is not being taught in the universities, then you stand a big chance of losing that knowledge going forward. Another critical barrier is IT infrastructure. It's currently, from my perspective, a major barrier, and of course, Helga knows how we've been working hard to try to bring up to speed our infrastructure platforms to be able to take advantage of these new tools and products coming out of modeling. So it's going to be very, very critical. And unless Geological Survey Organizations make the right kind of investments to strengthen and future-proof their IT capability and stay abreast of what is happening across the IT sector, it's going to be a challenge going forward. So funding has to be made available to organizations to be able to lead research in that area. I don't see that much happening. Another critical barrier that I consider is a lack of industry standard for visualization of products. So you have multiple visualization tools, and it places end users in a difficult position as to what tool to invest in when. And so there's a need for harmonization of tools and have so many tools, and that is a challenge for us as users of those products. Organizations have a difficult choice to make in making investment decisions and the rest of that. And users also find they struggle to cope with multiple kind of tools. And finally, public sector organizations especially lag behind in acquisition of up-to-date technology and tools. So it makes the uptake of those innovative tools that are being developed to be, especially with 3D, to be taken up. I recall the first time we made a foray into this. We had to find ways of creating that in PDF format, didn't we? And very useful visualization and readily deployable, but then you have to find a standard in industry to be able to do that.
Yeah, thanks, Michael, for just sorry to cut you off there. Just to reiterate, you mentioned the skills and a lot about IT infrastructure and the accessibility. And just to sort of quote Roland Baumberger from one of our 3D workshops, we had a great analogy of that the front of the train, there's no point having a great engine and a great locomotive who gets faster and faster and more technology and leaves behind the rest of the train with the passengers and we almost had the coal wagon at the back. And if the train isn't together, you start to lose the people who you actually were meant to sort of be transporting. So very much aware that we are in the Geological Surveys Organizations, we have to be mindful of the consumers and their technological capabilities. So back again on that note of the barriers, and I suspect Scott has probably got something to pick up here to do with technological barriers. Scott.
All righty. Certainly technical barriers. The being able to communicate once again is vital. I think one of the biggest barriers that I see from kind of a public perspective is you need somebody to champion these things. Our 3D mapping was done when my predecessor was here many years ago. And shortly after the 3D mapping was done, she left and we were in a recession and my position was not filled. And so it sat vacant for several years and nobody knew anything about the 3D mapping. And so it really was not utilized. You need to have somebody knowledgeable as an end user who can champion the use of it and the application of it. So, you know, as I've been getting accustomed to my job, I've been relying more and more on the 3D model and mapping to communicate, and then having it in a format that allows me and others to use it is vital. If it's just a very technical thing that only a few people would have access to, you're not going to have anybody on a public level to champion it. And so our Illinois State Geological Survey has an interactive online mapping program set up so that anybody can access that and utilize that to understand the geology underneath us, and more importantly, the aquifers. And so where recharge occurs, where you have aquitards or aquicludes preventing infiltration, these are all things that have value to us as a end user. So you need to have somebody knowledgeable to champion it, and then the ability to communicate that information to others. And our State Geological Survey has just been wonderful as far as taking the time to educate me so that I can then champion it. And we're now working with adjacent counties to do the same thing.
Scott, that is a fantastic point. Echoed, certainly I'm hearing this from the British Geological Survey, that the role of knowledge brokers, and that's a term that's being used, so the data and all the tech needs to come with people who understand and champion. So a great note there. Can I just move to Helen Reeves, who was on the producer side, but is now in the private sector potentially consuming 3D data. So what are your barriers, if any?
So just to go through some of the things, but with more of my industry hat on, is really data availability and quality. We work on many different projects across the world, Jacobs, on infrastructure, assets, large build projects such as nuclear build projects, and availability and quality of data at the right time in a project as well. Ensuring across a project that these important data sources are exchangeable and interoperable, and having wider agendas within the businesses, but also within the client base that understand how to use these data sets and information. And of course, particularly around using the information in 3D, how to deliver and communicate uncertainty. This is the biggest challenge I think we have going forward in this area of using 3D geological data and geoscientific data, is how do we communicate uncertainty to our stakeholders which are not familiar with it, and assume that the visual image they see is real life and 100% correct. And of course, around that, one of the things we have at the moment, particularly in these sort of ever-evolving digital agenda, particularly within the civil engineering construction sector, not just in the UK but internationally, is the availability of well-trained graduate and postgraduate students that come out that are trained to a level that can actually join industry and proactively take part as soon as they set their feet in the door. I think also from the experience of working on big infrastructure projects in the UK, some of the big government agendas bringing visualization, data, interoperability together. So we have big agendas in the UK government around building information modelling, and it now being contractually integrated into the UK government's procurement system. And that really has driven extremely hard the use and application of 3D data, of course, originally perceived by our colleagues and architects in the architectural community, but now because of that BIM agenda, the 3D geological and geoscientific information is really now starting to be used proactively in most infrastructure projects, large and small, in the UK. And to do that, we need good skilled workforce to be able to use the various data systems and understand what they can do or not do, more importantly, with the data and information, and then how to communicate that with their client base.
Superb, Helen. There are a lot of questions being coming in the chat. We are considering, we're replying to some in words, and we will take some of these questions head on in later in the Q&A session. So has any of the other panelists, does anyone of the other panelists want to speak up about barriers? Who wants to go next? If not, I will point at someone.
No, Holger.
Yeah, go on, Roland.
Roland,
yeah.
I completely agree with my colleagues here addressing all these issues and difficulties and barriers, and I would like to add also from the inside of a geological survey the way of thinking. So we need to concentrate on the customers, that we need to change the way we work, because we live I think we live in a time with rapidly evolving customer requirements, and we need to be able to address them. So I think that we should focus more on flexible products and not on the mapping products. We should need the formats or need the requirements of our customers, because our customers, they want to use the data, they do not want to format the data, they do not want to reprocess the data. They need data that are readily or must be readily available, and I think that's one of the struggling points within a survey, to go to the customer centricity, to have the customers at the center of our thinking and daily work.
Very good, Roland. Customer-focused service orientated geological surveys, quite a new way for some to think about that. So Ed, did you want to add anything? You don't have to. We have plenty of questions. Yeah, go on. Go ahead.
Sure.
Go ahead.
Yeah, I think the last point is very important. You have to demonstrate a need, that there is a use out there for that data, you know, not just for mining or whatever, but across many sectors. And once you demonstrate the need, then I think you can get, or at least request, long-term government funding to support these kinds of efforts.
Government funding, and or increasingly, which is sort of coming out in some of the questions in the Q&A. We had some questions there about scale and size of models, and you can also tell by the composition of our panel, increasingly the funding of geological survey organizations is diverse, and we should put as a general statement here, I've just posted a very good publication in the chat, which has been compiled by many of the people in our 3D community. Everywhere in the on the planet, it has a different geological survey organization and a different makeup and political and funding situation. So there are differences, but certainly in the UK, the funding of the Geological Survey is mixed between public and private sector, where you are forced to look at the actual uses and use cases of your clients, such as the Environment Agency or the construction sector. Cool. Kelsey, you haven't spoken for a while. I can't see you at the moment. I hope you're still there. I think it's time to, very good, yeah, you are. It's probably time to move to our next question.
Absolutely. So question number 3 is, what kinds of skills will geologists need in the future to enhance communication with stakeholders? And what tools and skills do you feel those stakeholders are going to need to best utilize the information and data provided by these geologic survey organizations? So why don't we kick that off with Scott? I think it'd be great to hear from you in terms of the opportunity to enhance that communication with stakeholder groups, and maybe get some information from your perspective on the tools and that would be needed to be able to best utilize that information and data for the various applications. So why don't you kick that off?
Okay. Well, I mentioned before that our state geological survey has made the data available through an interactive online tool, and I think, you know, further evolution of that will be very helpful. Right now, a lot of the information may be a little bit beyond the average user, but I see making some modifications to the online tool over time, where that's something that I can then take to classrooms and public meetings. I've used it on a variety of projects. We had one where a golf course was proposing to put a new well into for irrigation purposes, but the community there uses a shallow limestone aquifer that really had limited capacity. And so to put a new well in to irrigate a golf course and putting the community's water supply in jeopardy really didn't make a lot of sense. But it wasn't until I could show the actual geology underneath their community that it really resonated with them. So it can be a very powerful planning tool, but it needs to be accessible. And I think as time goes on, the technology will make that easier and easier to do.
Absolutely. Yeah, great response. And I agree with you. I think that's one area, and we heard that quite a bit in day number 1, which was really, you know, what many organizations are working towards, is striving to get that information more readily accessible and into the hands of stakeholders. And I think it's, you know, equally as important, as you state, to make sure that that communication is getting back to some of these geologic survey organizations that are responsible for building and constructing these 3D products, so that they get that feedback to be able to kind of help fine tune them to meet the needs of stakeholders. So yeah, no, definitely. Thank you very much for that. How about we spin it over to Ed and get an impression from yourself? I know you work with quite a wide range of stakeholders as well.
Yeah, I mean, it's not just geologists that need to work on these types of massive projects, but you need, you know, other people with other skills, geostatisticians, people that work with, database experts, computer scientists, and so on and so forth. I think use of visualization tools is really important to get the message across. Some years ago, we were quite involved with the high-level nuclear waste program in Canada, and several years ago, we got together at a virtual reality visualization lab where you can see things in 3D, and us modelers sat down with the geologists, and this was at a real site, not for high-level disposal, but an underground research lab, which we're building numerical models of. And it was so valuable to sit down with the geologists in a 3D visualization lab and point out features back and forth to each other and really get a better grasp of what the subsurface looks like. And, can we represent some of these things in our models? So that was quite a valuable exercise for us.
Oh, no, for sure. That, yeah, I can see that, definitely. Great points there.
Yeah, I was just going to pick up and we'll start to weave in some of the questions. Any thoughts on whilst we talk about the visualization and the tools, any thoughts from any of the panelists on the issue of that as soon as it's visual, and Helen touched on this a little bit, as soon as it's very visual and pertinent, that you might overestimate the certainty or the confidence in the models. So, and there are questions about that in the Q&A. So, is there a problem in becoming too visual and too immersive and forgetting what the confidence and the limitations of the models are? Any quick thoughts on that, perhaps?
Holger, yeah, absolutely. When you show somebody who's not familiar with geological data and geological maps and how the data is created, it very often happens that they see a definitive visual picture, especially working with a number of colleagues in planning, also working with people that are the general public. A lot of the general public think the ground is black and you can't see through it. So trying to get them over that hurdle, that what things look like beneath their feet and what the impact of that is. And when you show them a beautiful, highly technical, coloured block diagram, of many of them see that as absolute reality. So we need to think of clever ways that we have done for many years on maps. Are there visual ways to integrate the uncertainty into how we generate those visual things? And working in public stakeholder events when you're trying to show subsurface data around very sensitive topics like radioactive waste disposal, carbon capture, big projects, fracking projects, for example. There's lots of sensitivity, and of course people will take data and visuals at face value unless they know otherwise.
Superb. And back to Michael Kehinde's earlier point, if we to open up the secret society we've got on the talk, if people have missed it, they will all be on YouTube in the coming weeks. On Monday, was it Tuesday? I don't even know what day it is quite today. I think it was Tuesday. Michiel van der Meulen from the Geological Survey of the Netherlands did in fact show Helen a black slide as to what most people think of the subsurface. So we want to illuminate and open up the secret society, but then we are worried about showing too much certainty and too much confidence. It is a balancing act, and I think the skills and the explanation, the championing that we talked about is a very big part of that.
Holger, can I just ask one extra element? Many of us, through our formal education, are very poorly taught science communication, and certainly the skill set that we need as geologists going forward is how to communicate around tricky subjects and actually have formal training in our very early careers. or in university training around that. And I think increasingly that topic is being taken up by a number of universities, but it is something that I think is almost a necessity in many courses now. And it'd be nice to start seeing that as a more common module that people take.
A great point, and I bet most biologists are wishing they had been taught communication skills as we speak. So super point. I'm going to do a quick bit of admin here. Layla keeps prompting me to announce that we have a set of questions in a poll, which is which will be posted now on the announcement trail. And if you could take a few moments to answer the questions in that poll, that will also inform a little bit more the topics towards the end of the session, and yeah, make it a little bit more interactive. So and keep posting those questions. We will not ignore them. We will take them up in our end Q&A sessions. So Kelsey, if you could, I think, progress to the next question.
Sounds good. So thank you guys all very much for a great discussion and some great points thus far. So the last question as part of the panel discussion is, with many geologic survey organizations that are building models using information from data sets which are commercially and/or politically confidential, does data confidentiality limit how far these geologic survey organizations can collaborate with commercial sector and or make their data sets widely available? So we'd like to get your thoughts on some of the issues surrounding data confidentiality. How about we start with yourself? How about Dr. Helen Reeves? We'll start with yourself.
Data confidentiality, real tricky one with sensitive topics and big infrastructure projects. Always there. Really as part of project protocols because of litigation, certainly from my experience of working in the civil engineering sector. The limitation it gives after projects are finished, though, I think are quite vast, and we need to think about putting limitations on that so that once active live projects are finished and all the legal potential challenges have gone, that data does actually come to the forefront. Increasingly, I think that's becoming much better in the industry, particularly now with the view that sharing data across the industry is a much more common practice. I think that putting a time period on the confidentiality is an important part, and how to mandate that with any legal rules and regulations that come in within a country about access to ground information and being able to store within a geological survey is extremely important. I think within the commercial sector now, we see the value of sharing and storing data sets, which can then be used many times. So I think the perspective that commerciality and confidentiality is changing quite rapidly.
Yep, super. I know all of the panelists have got strong opinions. Some are on this topic. Did someone want to speak there from the panel? I didn't want to interrupt. Otherwise,
yeah, I was just going to say I agree with that comment of, maybe on a case-by-case basis, and certainly when projects are finished, that private data becomes available. Kelsey would know, I think in Alberta with oil and gas and all the drilling and so on that's done, isn't it after a certain period of time that data becomes available?
That's correct. Absolutely. Yeah. So there's a certain period of time in which we can't, we wouldn't be able to use it, or we wouldn't integrate that within the models that we would be sharing. But after, that confidentiality comes off, we're able to integrate that data into the models and share it externally.
Yeah, I want to hear from all the panelists on this one. So if we go, I know Roland has got a long history of battling with data availability, in particular as Switzerland is a federal state, just as Germany, the US, and Canada is. So perhaps Roland next from the GSO or the survey perspective, and then, yeah, I want to hear from Michael and from Scott as well on this, please.
Thanks, Holger. Yes, there's no doubt that we need the private data to build up our models, so we have to fight with the data owners to share them. I think from our perspective as a GSO, we concentrate on the data of national interest to serve our models and to build our models. And these data of national interest, it's about 20% of all the data, geological data existing in Switzerland. So the battleground is much smaller than if we go into the real details of all the data. We have established quite a good working business model. So the private companies, they supply the data for us to work. We can work with the data. They receive our results as some kind of our contribution to this collaboration. And as long as we do not publish the confidential data behind, then we are allowed to publish the results finally, for example, the 3D models. But we do keep the points, we do keep the information, where we have data, which data is used there, and we will publish these data in an anonymized form, for example, with data coverage maps or point maps where we have the boreholes and the wells. And I think that's the important way. If you can use the data, but if you are not allowed to publish the background data, then it's necessary that you are allowed to publish the metadata that you still need, or still know, that you still know which data was used to build up the models. And you can also share this information that the users, the customers, know which data is the background of your models finally.
Very good, very good. Exactly, that's the challenge from the Geological Survey Organization side. So perhaps quickly from the Environment Agency, who is a producer of borehole data themselves and shares and consumes, and then maybe Scott if you have a comment on that note as well. So Michael first.
Yeah, thank you very much. With respect to data, I believe that confidentiality with respect to commercial and political sensitivity is essential. I don't see any big challenge with that, because data is a lot of money, and people have generated data using their money, and they want to benefit from that. Having said that, I believe from the Environment Agency perspective and the UK government perspective, we're now moving towards open data policy, so that our data which we generate are readily available on open government license. So that is not a problem anymore for us. With respect to private sector generated data, I believe where it comes to especially borehole data, we have regulation in the country that requires all such data to be provided, and the British Geological Survey is the national depository for all such data, and that is readily accessible to people through the website of the Geological Survey. Where there is sensitivity, the data can still be used in producing maps and other tools, but again, like Roland said, you can publish that information, that processed information, but you don't have access to the metadata behind it. So that's a way to overcome this. And users and stakeholders are mostly interested in that final product and having the understanding that the data behind it is robust and they can trust that data. And that is where building relationships and trusts comes in. It's very essential in getting access to data.
That's a very, very, very good point, Michael. It's back to my presentation on Tuesday. That trust does come in, trust and collaboration, and that also links nicely across to sort of Scott's opening point of people who come with the data and the information and connect. And make sure that data is used in appropriate ways. So yes, Scott, did you have any final comments on that overall questions of data that is held and locked up for commercial or political reasons?
I guess my exposure to the 3D mapping is strictly public. So the funding that we put into our 3D mapping, is for public use. So I don't know that we have the same issues as a private company doing specific work. That may come up in the future as we start doing more and more of these types of things. But we want the information to be accessible to the public. I guess the one area where we've talked about this type of thing is in regard to aquifer sensitivity, and by showing people where the most sensitive areas are we opening those up to be targets for sabotage? And we've got enough problems with industries causing pollution inadvertently that we've got bigger issues to address, and the mapping can help us with that. So I don't know that we have the same privacy issues that a privately funded project would have.
Very good. And again, I referred to I have posted in the chat in the Q&A one of the reports that this community has put out now in second edition, Kelsey as the editor-in-chief there, which is summarizing individual constituent jurisdictions or countries situation around the world. Again, here just the caveat: everywhere is different. So we have some states where the data is highly regulated and the government organizations have full access. So for example, we have also information from China, and we have Singapore as an example where data is available to government organizations. And in other areas we have data partially available. So for example, Michael mentioned the Water Resources Act stipulates that data is collected. But where we find it particularly challenging in the UK, and this is sort of Helen's domain, is boreholes, site investigation, ground investigations for infrastructure and construction projects, for example, are the big missing component in the UK. But again, we have a publication, I will post it again in the general chat, where you can go and browse the different situations in different countries around the globe. So, Kelsey, am I right that we are now closing the general Q&A panel session off?
You are correct. And so definitely I'd like to kind of wrap this up with a huge thank you to our panelists, Scott, Michael, Helen, Ed, and Roland. And now what we're going to do is transition over to the discussion session, which we're going to get to a number of the questions that have come in. We want to also bring up some of the poll results. So if you haven't had a chance to go and fill out some of those poll questions, please do. And we'll pull that up, and we're looking forward to a really fruitful discussion so for the last 45 minutes of this session. So what we'll, again, huge thank you to you, and we want to keep all of our panelists and have them available so they can chime in on some of the questions questions that are coming up. So yeah, again, keep the questions coming, and if you can, like some of the ones that are there that you'd like to hear more about, and we'll try to get to those ones that are in kind of greatest demand, that have the most people want to hear from. So we'll transition over into that one right now.
Yeah, and it is interesting. So the most upvoted question is, of course, to do with our favorite topic of uncertainty and showing models that might show more confidence and certainty than the user expects. So I have posted in our green room here to our panelists if anybody is prepared to take this on, and no one has put their hand up. So yeah, the question here is, have any of the panelists considered the issues of liability when models misrepresent the subsurface? So Hazen, who's in our room, has already given an answer that usually there are caveats from the Geological Survey side, and the responsibility of models sits with the user. So that is a sort of a one part of the answer. Anybody wants to put their hand up here and have a go at this meaty question?
What?
Yeah, Michael.
At the Environment Agency, and in particular for the water resources regulation that we do, the 3D models that we create are kind of integrated with our groundwater modeling models. So they kind of form the basis of that. And we do explain to those we regulate that the models are just there to simplify things for us, and there's no right model anyway. So model uncertainty and is communicated from the beginning to help stakeholders understand that this is a reliable tool, but it is not a perfect tool. So we work on that basis. So the issue of liability then is much off the table. We try as much as possible in building those models to involve stakeholders from the very beginning, so that the end product we have is a jointly owned product, and that helps us to avoid any kind of challenges and litigation based on any decisions we've taken on those models, because it's jointly owned by the stakeholders.
It's a great response, Michael, and I agree with that. I know there was a great quote, I think it was Box 1976, which was, all models are wrong, but some are useful. So, you know, it's these models they're a version of a reality, and I think that's what's going to become incredibly important from you know, from a data management perspective, but model management perspective as well. So, you know, models are generated and they're used to support decision making. I think in this case, as models evolve through time, as more and more information becomes available and we update those models, it's going to be important that we retain that, you know, the metadata and the kind of custodianship of those previous models that were used to make decisions, so we can go back and have a look at what information was available at that time to make those decisions. Because absolutely, it's a great question. And it's certainly something I think that you know, we ponder and consider and are concerned about in terms of the liability associated with models that are derived. They really are a version of reality, and again, it really harps back to that communication component and the necessity for great communication, in that there is uncertainty within those model results, and we need to make sure that decision makers are aware of that.
Yes, I think pushing the responsibility to the client, to the user, that's one side. On the other side, we have to make sure that we did our best and did undertake everything we can to deliver the best product or the best data we have. Additionally, we write technical notes on how these models or products evolved, how they were developed. We have release notes for every version that comes out every year. We add release note what has changed with which data were used to model the update. I think that's and then we add disclaimers on our websites, and they are also included in all these notes. And that's not enough. We have currently an example. We published our top bedrock map in 2D with a cell size of 250 meters. The original format is a 25-meter cell size, so this cell size was scaled up to be able to visualize it on the web. And still there are people using this 250-meter cell size for detailed local studies, and now they wonder why their model or why their prediction is not correct. So then it's our responsibility to tell the people how this model was produced and to which extent they are allowed or they should use the data. And then we should add additional information in the visualization, in the visual communication, and to make clear that these models are wrong. The models are wrong, but we have to clearly communicate that they are wrong and to which extent they may be used.
Great, Roland. Yeah, sorry.
If I could add something to that, when we build the 3D flow models, we generally talk about two types of uncertainty. One is what we refer to as structural uncertainty in the model. In other words, did you get the geology, the geometry of the geology, layers, extent, thickness, resolution, etc.? Did you get that right? And then to do the flow modeling, you need parameters, hydraulic conductivity, porosity, etc. Those are also uncertain parameters. Now, geometric or structural uncertainty in the model, it shows up pretty quickly because you're comparing your model to field observations of hydraulic heads, whatever. And you'd have to actually torture the model with unrealistic flow parameters to try and get a match. Now, if your structural model is reasonable, and then you have to deal with parameter uncertainty for what are the properties associated with each of the geologic layers. There are formal ways we can handle that to propagate the uncertainty of the input parameters to the uncertainty in the output parameters.
Really good. Thank you. And spot on that, almost as if we'd planned this, feel more and more like a BBC Radio 4 podcast here. Helen is just going to come in on how the engineering geology community sees the difference of models that you just so well described from the hydro perspective. So, and I'm posting an article in the chat there.
So fundamentally, we start with developing the conceptual ground model. That bit can be just from desk study information that can be acquired. That helps us to then generate planned ground investigations. And then comes in another type of model where you start bringing in some of the more analytical data and information from that ground investigation. Now that can be from a monitoring program, as we've just heard about, groundwater monitoring, or it can be from a geophysical survey, geochemical survey, bringing in all those different data sets to then generate more of your observational model, which takes the next step in your conceptual ground model, putting some observational characteristics to that model. And of course, then there is another type of model that a lot of us work with, more commonly used in the oil industry, but occasionally used in the ground investigation, civil engineering community, where you start to create analytical models from data. Interestingly, those two sorts of test techniques using more statistics, techniques, stochastical models, etc., enable us to start understanding uncertainty in our data But of course, they rely on large amounts of data sets, which often in the engineering projects is more of a challenge, and increasingly, and certainly outside of the UK, data and information is hard to get to for some of these projects. So it's very important when you're creating your conceptual ground model, you start to think about the data and information that you actually can acquire to help create that data information model.
Super. So yeah, the difference is, and really important, just to reflect on Roland's point, just throwing some data numbers over the fence is never a good idea. It needs to come with explanation, with narrative, with expertise, and not just with a communication of some confidence in numbers. And Helen, thanks for the quick, and Ed here for the quick explanation of the differences between a conceptual model, which just gives you a rough indication of the subsurface, and an analytical model, which might be used in engineering design or in oil and gas or groundwater extraction. So, Kelsey and Leila, we have, sorry, Roland, just a very quick one.
Just a very quick remark. I think keeping the models safe, keeping the models in secrecy, that's not the point. That's not the way to go. We have to publish the data, but we have to also to provide additional information how to understand and how to use the data. We are, as geologists, we are not the keepers. We are not the gatekeepers of geological data. We have to bring them out. We have to publish them, that people can use it and understand the subsurface, so that subsurface does not remain a black surface or a black slide, as Michiel showed 2 days ago.
Cool. Sorry to cut you short there. We are an hour and 15 minutes in. Kelsey and Leila, are we going to reveal some of the poll results? What's the plan here?
Yeah, this would be great. And thank you to everybody who has gone into the poll and responded. I think what we're going to do is flip those up and hopefully be able to show those to you guys shortly. But it looks like there was about 70. We've got about 76 responses here. So the questions that were put forth were, how would you characterize your primary interaction with geologic models? So we wanted to get a bit of an idea on how many people we had that were developers, so building models, the users, researchers, or fans. So they don't use the models, but they're really interested in those. So again, that's a great group for us to target and get engaged and bring on board and get people utilizing those models. So you can see we've got, in terms of the respondents, we've got quite a few model builders out there, which is great. And what's always fabulous to see is the number of users. Although, we'd love to kind of see that number increase and get more and more people using models for those applications. So that's great to see. And the next one was, do you use 3D geologic models to make decisions? So this is great to see. We've got quite a number, just I guess shy of half there, that are currently using 3D models to support decision making. So that's great. And quite a number.
Live dynamic models here, very good.
Yes,
I like it.
Yeah, so we can be refreshing these as people are responding. So as you can see, we've had 4 more responses come in just since we started sharing the slide, the polls. So yeah, keep those coming in, and Leila will kind of refresh, and we'll see as they kind of change. But it's great to see that there's quite a number of people that are looking to use these models in the future to support decision making. So which of the following data do you prefer to use? So we wanted to kind of get a sense on whether you'd prefer to go out and get the models from people and use those, whether you would prefer to just stick to 2-dimensional data, and then that could be for a whole variety of reasons. Maybe it's just not having access to software or visualization software, or maybe not fully kind of having that kind of confidence in how those models were built. So there's definitely a a small percentage, but definitely a percentage that are saying they prefer to stick to two-dimensional information and data. And then the green, which seems to be kind of the largest percentage right now, is people want to have access to that information and data so they can go and build their own models. So this is an interesting question and an interesting area, because as part of some of the geologic survey organizations, as Roland mentioned, I mean, we have massive amounts of information and data, and a big or a part of our mandates is to make that information and data accessible. And so what we want to try to make sure we're doing is, as those models are being built, that we're communicating, as was stated by Helen and Ed and others and Scott, we want to make sure that people have that confidence in how the models were built and the reliability, or I should say the uncertainty that is associated with those models, so that people feel comfortable using them. But it's equally as advantageous to make sure that we're sharing the model components, so the data that's used to build those models, so others can go pick up that information data and build their own models. So it's great to see that there's a lot of interest in that as well. And then the last one, which really kind of leads into some of the questions we've been seeing in the Q&As, which is to do with like the 3D software applications. So this one, doesn't get into naming specific software programs. However, we've bucketed them into like open source software, proprietary, and so examples of that would be GoCAD, Petrel. Those would be some examples of proprietary software packages that are used, or if potentially some groups just rely on 3D website platforms. So they're going in and visualizing 3D models in an online platform. So, and maybe can you scroll just a little bit more? I think I'm missing.
Just one sec, Kelsey. I've just seen a post and also had a reminder from our back office that we should remind people where the poll is. So can you just remind, is it, because I can't see the other side, should we post a link?
Yep, the link was posted. It would be from the moderator. It'll show from a moderator, and it would be probably further up. I think it was posted a little bit ago, but perhaps what we could do is have that posted again, the link kind of reshared, and so people can provide some additional provide their thoughts, because yeah, we definitely want to we're interested to hear from as many as possible, and we're up to 90 responses thus far.
Cool, thank you. Sorry.
No, that's great. So what the plan will be is yeah, we'll maybe jump to some of the questions, and we can kind of come back to the poll results in a little bit and see if we've seen any kind of dramatic changes since this time.
Yeah, thanks. Yeah, it fits. I mean, it flows very nicely, Kelsey, from what you just ended on. There's quite a few questions in the chat, and it's becoming a very clear picture here. So please be assured that we are not just doing this all for fun and being clever with our live updates here. We are a community that meets regularly, and we do things like publish our synopses. We're publishing a book right now as well, and we're taking away here that a lot of people are asking again today about what software, what tools are available for me as a starter or as a student. So again, we're going to not name individual article software today, but it's becoming clear that there is a need to perhaps make some sort of resource available. I have posted in the chat the publication I keep referring to, which is our synopsis of 3D geological modeling organizations. That does have a very good overview of all the tools used by the various geological survey organizations. And really, that is one of my other suggestions. You can always pick up the phone and ring a friendly geologist in your local jurisdiction and see what they use and see if they can help you. So cool. I'm now going to have a look in and keep upvoting the questions. We've dealt with a couple of the most liked questions. So we have how can students learn, interoperability. So this is one that is a bit like the term metadata or the term uncertainty, where usually we head for the bar if we could. So if anybody still has the energy on the panel to maybe give some thoughts on the problems that the audience certainly thinks we still have with interoperability between different packages, and I suppose that is a question that we had before also with the user communities. So the point is we do need a standard for 3D data. Anybody on the panel wanted to have a go at that? And as I said, it's one of those topics because I mean I can give it a go, and Kelsey, I mean as we said on Tuesday, we've been through this over the years. There is no there's no silver bullet here. There is interoperability between some software tools. There are some de facto standards are emerging, so we're exchanging 3D geology at the moment via the CAD. That's the general CAD and GIS formats and grids. There is a working group at the Open Geospatial Consortium. There is also a working group between all the all the various geological survey organizations, but things are in the making, but we have no magic answer right now. That's just a bit of an opening statement from me, but anybody else?
Yeah, I could jump in on there. It's Kelsey here. You know what, I think exactly as you said, there's no magic bullet. It's, you know, many software packages are used and formats are used, you know, based on the needs of each individual jurisdiction. And it could be to the type of data they're trying to integrate, or it could be to the type of application they're building their models for. But it is key, I think, as we kind of saw on day one, and as you know pointed out in some of that synopsis volume, some of the reports that have come in from the various jurisdictions, most organizations are using more than one software package. So there is starting to become a greater ability to transfer data and models from one package to another. However, I tend to see with many of the software packages, they have lots of import formats, but very, very few export formats. So they want to definitely get your data in, but it's sometimes getting your models and your result out the other side that can be kind of challenging. So, but definitely I would have to say for myself, as a model builder and user, I've certainly seen the flexibility and the push towards interoperability increasing over the past few years.
We use databases that have all sorts of different storage formats. What we commonly do is we end up writing translators from one to the next, and also from a database into the model format. So things like that can be done, but it's awkward.
Yeah, Helen?
Just to say, we've made some real good inroads in the UK, very much driven by the ground engineering community in the UK. For nearly 20 years, the Association of Geotechnical and Geoenvironmental Specialists have actually got a data transfer methodology for raw borehole data, but now that's taken an additional step, and we're starting to look at transfer formats for ground models and interpretation data as well. So that's moving forward here in the UK. Known as the AGS standard for ground investigation information, is used not just in the UK but in other countries around the world, Hong Kong, Singapore, New Zealand, for example, now. So going some way to do that. I certainly know from some of the work I've done in the US that there's also the DIGS format, which is going some way to doing that again. Keith you'll be able to give a bit more update on how that's developing in the US.
Great, thank you. And I am. It's so hard to read and chat and communicate in all the different channels. So thanks for all of this, Kelsey. I think you just said that we were going to post one more question. Is that right? Is that ready?
Yeah, that's right. So if people can see, hopefully that question will pop up shortly in the Q&A session. I put out a question to see what topics related to 3D geologic mapping and modeling would you like to learn more about? Because we had lots of questions that were posed on day one and a number today as well, in terms of where to go for additional resources or people looking for additional information. So this is a really bit of a free form for people to put in whatever response you have there in terms of what kind of topics or areas are you interested in learning more, whether it's basics, maybe model communication, communicating uncertainty, or using 3D models to support decision making. It's really kind of open to you guys to respond. So yeah, please feel free to add your responses into the Q&A box.
Yeah, and really appreciative of everyone still contributing. I don't know what the numbers are at the moment, but it's certainly some really good quality questions and answers. So thanks for everybody on the panel and in the room behind us to answer all of those. Whilst that's coming in, I wanted to, we're coming up to sort of summary time, and I'm beginning to sort of think about a few key statements. I wanted to make sure one answer from Michiel van der Meulen from the Dutch Geological Survey is heard, and I'm just going to read. So there's a question from Nahid, upvoted to 15 likes now, about should we still teach students traditional techniques in the classroom? And the answer is importance, because we had a post-mortem chat. Again, I forget the days, I think it was yesterday or the day before. Michiel makes the point, please do continue to teach geology in all its shapes and guises, fieldwork, borehole interpretation, stratigraphy, map making, even, okay? And he makes the point that at geological surveys, we can teach good geologists how to become good modelers, but we can't make up for basic geological skills, which does include mapping, or maybe we call it surveying. So really important takeaway message that I think the whole panel and everybody involved in organizing this agrees that this is not artificial intelligence and machine learning. We had some questions on that, is not going to replace some of the fundamental skills and knowledge that you need in order to understand the Earth system. So, cool.
Holger, I can probably add something. I'm in the situation to teach an introduction to 3D geological modeling using a software once a year, four mornings, four times 4 hours. There are geologic students from earth sciences, but also students from geography, from the geography department. So, and as Michiel said, we can help the students to become good modelers, but if they do not understand the basics of geology, they will never be good modelers. So that's also the way I'm thinking, and that's also my experience. There is a gap between these two understandings, and I saw in the questions similar remarks. So there need to be a fundamental understanding to be good modelers, or to produce good models, else the 3D models would only be nice images or nice pictures of something in the subsurface. So I completely agree with this meaning.
Excellent, Roland. And just to
absolutely agree with that.
Sorry, Michael.
I absolutely agree with all of that. We must not forget that our primary focus is building geologists. That is the primary focus of this. And 3D modeling applications are a kind of enhancement to enable geology to be made to be illuminated, as Holger said. So we should not lose focus of that. And Roland, what you're introducing in your university there is quite excellent, giving geologists an opportunity to appreciate 3D modeling. That is a good way to go. But we must not abandon our primary work of building geologists, because we now have this tool. It's a tool to making geology better known.
Very good. So we have about, have we got 15 minutes left, I suppose? Leila, could you put the results of that final poll live, and we can just take a quick look at that. Oh, 145, so people have clearly found the link, which is great to see. Excellent stuff.
Yeah, so as you see it, I guess it looks like a kind of a similar proportion. If anything, it's grown on the research side. You know, we've seen since the last update, it looks like there's more kind of research academic interest in the models, which is great to see. But still, lots of developers, lots of model builders. So for the second question, you know what? I'd say we've got we still kind of split just under half there in terms of people that are using and would like to use in the future. So great to see. And in terms of that group that would like to in the future, this is a really good opportunity if you can maybe in the chat box, you know, maybe provide a bit of information or context on maybe what's stopping you from doing that, or maybe what you're looking for in order to be able to use those models in the
these
future.
Slides, these graphs remind me of Dick Berg, who's also in the room, I think. His remarks that the market is certainly growing. So if I was to look at that from a market opportunity point of view, there's definitely demand. So really good to see. If we can scroll down, we've still got some, And did we put out the other question yet that we were still going to put live?
Have we? That one's gone out in terms of the topic.
It has. Oh, sorry. Okay, cool.
So definitely, as Holger was mentioning, you know, you can definitely see lots of people that are looking to get to start using models to support decision making. So it'd be great to hear from people in terms of, you know, what you'd need to kind of get across and actually go from wanting to and to actually using them. But again, great to see so many people are interested. In terms of you know, utilizing the geologic data, looks like still the majority of people want to have access to the data to then go and build their own, make their own results or build their own models. So again, I think it just really goes to underpin the fact that, you know, we have to be able to put out the model and put out the data and the information, make sure we're equally sharing, you know, both components, because we have quite a number of people that would like to just pick up the model and use it, and quite a number that would like to be able to access the data that was used to build the model and maybe use it for their own applications. And in terms of 3D software applications, looks like the majority are using proprietary software, but still quite a number that are transitioning to the open source software types.
Very interesting indeed, I know, and this is one to pick up. I would love, of course, now if we had the time to now dive in and see how that part of the pie opens up. Very interesting. I mean, obviously there are open source sort of GIS platforms, but maybe people are beginning to build plugins and so very, very interesting. Thanks again, you know, for everyone for sticking with us and for responding in such great numbers. That's really, really, really useful. I wanted to just pick out a couple of questions from the chat. Kelsey, in fact, you remind me of the timings and the agenda just for quick before I go on all night or morning.
Yeah, no problem. So we're kind of coming up to the last 10 minutes here. So definitely, I think it's a good opportunity to ping on a few quick questions and then get into a summary for the
summary mode.
past 2 days.
So I just thought I could pick up and we do like a quick, every one member of the panel, I throw like a quick question at all of you for like 30 seconds. There is one here posted anonymously, and I wish we would know to some degree, saying there is bureaucratic fiefdoms tend to be turf protective, no access to data. And Michael has already responded that sitting on data is basically dinosaur behavior. And so just maybe one statement from Roland Baumberger to sort of, what is it with our fiefdoms and our protectiveness, and is the future open access and open data? Just a final sort of 30 seconds from you on that.
As I already said, that's dinosaur behavior. That's gone. So we have to publish the data. Data is the key to everything. So publish the data, and then that's good for everybody. That's good for building the models. That's good for transparency. Yes, data.
Very good. We have, go on, Kelsey, sorry.
Definitely in the UK, we are on that trajectory of open access to data from the public sector side. The UK government is encouraging open sharing of data wherever it's available. Actually, the reasoning behind it is quite simple. It's been acquired with public money, and the public have the right of access to what was acquired with their money. So
very good point.
Yeah.
Yep. Democratization of science and the democratization of data. Very good. Maybe one for the other panelists to put there. So there is a quite a high upvoted comment here. We've touched on this, but maybe some final thoughts on the. It's upvoted on 13 with 13 votes here. My experience is in universities we have too much technology, too fast. Newer colleagues view AI and ML as the answer to everything without need for ground truthing. So I know we've been through this, but possibly Ed, Scott or Helen, some thoughts about, is too much tech and too much AI and digital twins stopping us from focusing on the basics?
Observational data as a geologist is key. The more a geologist sees, the better they can do their interpretations and modelling.
Great. Anybody else on that point?
I think you need to keep your feet on the ground. When we build our numerical models for flow and transport, I mean, we have to compare our model output to actual observations. Now, where we sometimes use, let's say, more advanced technology is in, for example, importing field data in a live stream for the purpose of data assimilation to improve the model periodically through time. This is very useful, but it's also not that complicated, but we're still relying on the basic underpinning of the data to drive the model.
Yeah, I would agree with that, Ed. I think it's an interesting comment too. I agree, we want to have data-driven models, but one of the ways that these applications, AI, ML, can be used is actually to filter through, go through information and data, and actually identify areas where we have major issues. And so we can focus our geologists and geoscientists to those areas, the really complex, tricky ones, because you're right, we're not going to, there's no substitute for expert geologic knowledge, and we want to make sure that we're optimizing that so we can, and that's, I guess, one of the ways that we're trying to leverage these applications is to focus our geologists into the areas where they can have the biggest impact on improving model uncertainty and complexity.
And
cool. So,
well, we
yeah,
can also
sorry.
we also have algorithms to compute sensitivity of the model input through time. So we can look in different regions in space and different periods of time when certain parameters become more or less important. And that really helps us to build more reliable models.
Very good. So I have posted in our internal room whether anybody is still hungry to take a bite at a very sort of slightly philosophical comment from Jean here. And hi, Jean, thanks for listening. How do we address the issue that if scientists aren't certain, the public trusts us less when we talk about models? And of course, we have all been seeing models and predictions and graphs more than we would ever care. And I think there is an interesting parallel to the communications of predictions to do with COVID. So can anybody feel out the energy on the panel to have a go at how the public might not trust us when we talk about models? And then I will draw it to a close. Thanks for the prod, Kelsey.
So just a starter, I think we are talking about the interpolation between points and lines. So we are talking about not the nothing between the points when we are talking about the models, and that must be clear, and we must be confident about that fact by ourselves. And I think the difficulty is to address this issue also to the public. And I don't know whether it's if we make it transparent, then that the public trusts us less. I think regarding the subsurface, they could understand us if we treat that fact in transparency. I don't know. I'm unsure.
I would want to think that if we are very, very transparent with the fact that we don't know everything, but what we do know, and from our professional judgment, this is the situation, and we let them understand this is the weakness of that because of this, and we explain to the public. They're not looking for people who are who know everything. They want people to show their weaknesses so they can relate with you, because they are as well not perfect. So the important thing is that we must trust our models, we must trust the data behind them, and we must be ready and willing to expose the weaknesses in those products and let them understand that this is our professional judgment and we think it is right.
Excellent stuff, and really good stuff. Almost finished here. Just a couple of words from Scott on this.
Just real quick, and I appreciate everybody's comments regarding the limitations of the models. But when I'm working with the public, I do emphasize that our State Geological Survey has been really good about communicating that with me, and I usually will use the mapping as a tool, and that's how I describe it to people. Is it is a tool, but then I will refer to bore logs and other data to reinforce the information, not rely just solely on the mapping. If I have other information available, I'll use multiple sources and just relay the uncertainty to whoever I'm talking to.
Superb. So I'm going to do what usually is falls to Harvey Thorleifson. If we were all in a room together and summing up in a very quick manner. So obviously, thanks to everybody who's joined and contributed and listened, and thanks to everybody on the panel today. People who have helped organise in the background includes Tim and Katie from the British Geological Survey, but also, of course, Chris and Layla, who you won't see or hear because they're just doing the stuff in the background, making sure we all keep to time and the technology works. So we've heard today about barriers and skills and infrastructure, and really what came out, we need champions for the models and for what we do. And Helen's point that she said she wishes that we learn communication of science and early on in our careers, and that is a great point from Michiel van der Meulen there in the chat here, that people have learned to understand weather predictions and weather forecasts, and that's because we have fantastic science communicators and visual tools to get the meteorological forecasts onto our screens, and we can all live with the uncertainties, and we look at the wind and the clouds, and we make up our own assessments with observational data and forecast data. So lots to learn there. We will definitely look at all your comments and look at where are the resources, how to get people started, but definitely the market is growing. The pie charts are speaking for themselves. We've touched on communication of uncertainty a lot, and in the words of Michiel again throughout the week, we sometimes also just need to do, and me and Michael's points about exposing, being honest with our uncertainties is a great first step, and communicate clearly. So Kelsey, as my co-chair, do you want to have a final couple of words before we draw this to a close?
No, I would just like to say thank you to everyone who participated, and for the great presentations and commentary and discussion that has followed both of these two sessions. So I'll let you take it away, Holger.
Yeah, thank you. And we look forward to potentially seeing you in person somewhere, maybe somewhere in the world in next year. Stay safe, everyone, wherever you are. Have a good day, good morning, good evening, and keep on modeling. Thank you, everyone. Bye-bye.